We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 15, Exercise 15.4. The inside perimeter of a running track is 400 meter. The length of each of the straight portion is 90 meter and the end are semicircles. If the track is everywhere 14 meter wide, find the area of the track. Also find the length of the outer running track. So we have to find out the outer running track length, that is the perimeter of this, because inside perimeter is already given. It's 90. This from here to here it's 90. Let me show you. From here to here it is 90. From here to here it is 90. So 90 plus 90. Let me just assume that I'm taking the internal one, say length or track. So this is the internal track. This is 90. This is 90. This we don't know. This we don't know. So how to find the interior one? Circumference of semicircular portion, this one. See, this is 90, this is 90. So we have 90 plus 90. That means this side is 90, this side is 90. We don't know this one. So let us assume it to be x. This is to be x. So just say that 90 plus 90 plus you have 2x. Let us assume that this is x, this is x, so 2x. This is equal to given 400. So 2x is 400 minus this 90 is 180. This is going to be 220 2x. So x is 110. So we have the circumference of this portion, half portion is 110. So now this is what? This is half of the circumference. So half of this circumference, which is 2 pi r, is 110. I am talking about this portion only, this portion. So this is going to be 110. What do you get? You can just put half into 2 into 22 by 7 into r equal to 110. You get r as 35 meter. So the radius is 35 meter. This radius is 35 meter for the internal semicircle. But this one is how much? The width is everywhere 14. So you just add 14 with this. This is r, which is 35, and this is 14. So 35 plus 14 is, this r is internal and this r will be external. E I'm writing. R external will be 35 plus 14. So which is 49. Now what is the length of the outer perimeter of both the semicircles? See, this I'm talking about and this I'm talking about. So it's a circle basically. If I combine these two, like this one and this one, it is a circle. So I have to find 2 pi r. 2 pi r of both of these, this one and this one. So 2 pi r, as I said, 2 into 22 into 22 by 7 into a radius. What is the radius of the outer one? 49. So 7 7 is 49. What do you get? You get 308. This one and this one. Now this is 308 and this is 90 and this is 90. So 308 plus 90 will be the outer boundary or outer length, and this is going to come as 488. Okay, so we got the outer length. And what about the area now? What about the area of the track? So what we have to do, we have to take the outer area and we have to take the inner area and subtract it. Then only we get the internal area. So from here, we will take them separately. First, this part and this part. So here the length is 90 and breadth is 14. So we have 1 and 2 parts. For 1 and 2 we have 90 into 14. This is the length and breadth, this is length and breadth, and we have 2 of these, so we multiply it by 2. Okay, this 2 into 90 into 14 is the area of this side. And how about this? If just see that I'm taking this part, half part, and this part, and I'm combining it. I'm taking the half part. I'm just eliminating this one. So this will be actually a circle. So we just want to find out this region. So I have to subtract them. I want to have this region. So I'll take the area of the outer one and I have to take the area of inner one and subtract it. So what is the area of the outer one, which is pi r square, because I have made a circle out of these two, combine this. So it will be pi r outer, r external square minus pi r internal square. So this will be what? I have to add these two. So this will be around, say, this one 90 into 14 into 2, and then we have 90 to 42. This is going to come as 2520. This will be 2520. And what about this one? Pi r e square minus pi r square. So it will be 22 by 7 into pi, that is pi I've already taken. R external is 49 square. This is outer one. This is 45 and this is 49 and this is interval is 35. So 35 whole square. So when you solve it, it will come as 3696. So you have to add 3696 with this 2520. That means you have to add these two with these two, and you get the answer as 6216 meters square. Find the area of the figure in square centimeter correct to the one place of decimal. So what we have to do, we just have to take this area and this area, but we have something here also. Let me just join this. So we have joined this. So first area is this rectangle. First area is this rectangle. Actually, it's not a rectangle. It's because this is 10, this is 10. So it's a square. So it's a square. 10, 10. Sides are same. So the area of the square plus area of this semicircle minus this area of the triangle. Area of the triangle. This is what we have to do. So what is the area of this is semicircle? Let me write it as C. Area of the square is side square. So we have 10, 10. So 10 into 10 is the area of square plus. What is the area of this semicircle? It is half into pi into r square. What is r? 10 by 2. Okay. Now I have to subtract this triangle. Now is this triangle, we have this as 90 degree. So I can take this as base and this is as height, or this as base and this is height. So the area of triangle is half into base into altitude. So half into base into altitude. So 10, 10 is 100. Then we have this, this will come as 39.28, and this will of course be 2 4s are 8, 6 4s are 24. So I have to subtract 24, and this will come as 115.3 centimeters square. In the figure, they form a rectangular region. Now here AB, CD with AB now as 20, a right angle AED. So this is a triangle right angle at this AED with AE as 9. This AE, this is 9, and this is 12. This is 12. On the other hand, taking BC as this diameter, we have made a circle, semicircle out of it. Is added outside the region. Find the area of the shaded region. So we have to find out the area of the shaded region. Same thing we have to do, area of the rectangle, area of the rectangle plus area of this semicircle and minus area of the triangle. This is what we have to do. So area of this rectangle will be simply 20 into this side, but this side we don't know. So how to find this side? Because if we find this side or this side, we'll be able to find out the radius also for this semicircle, and we'll be able to find out the breadth of this rectangular part also. So this is 9 and this is 12. What this will be? This is a right angle triangle. So this is 9 and this is 12. So what this will be? 9 square plus 12 square under root, right? So this is going to be 9 square plus 12 square. This will be 81. This will be 144. You add them, it will be under root 225, and this is going to come as 15 centimeters. So this side is 15 now. So we are now knowing this side. So we have area of rectangle as 20 into 15 plus area of the semicircle is half pi r square. So half pi into this is 15. So radius will be 15 by 2 whole square. And then we have to subtract the area of the triangle, which is, see, this is base, this is perpendicular because this is 90 degree. So half into 12 into 9, base into altitude. So this 20 into 15 will be 300. And this one will be, you can just write it as say 88.39, just compute it and just subtract it with this 54. This is going to come as 334.39 centimeters square. From each of the opposite side, two opposite side, these corners of a square of side 8 centimeters. So the square is of 8 centimeter. A quadrant of circle of radius. So there are quadrants, two quadrants of radius 1.4 centimeter is cut. Another circle of diameter 4.2. So this is a circle inside which is having a diameter of 4.2. is also cut from the center. Find the area of the remaining or shaded portion. So what we will do, we'll find out the area of this square. Then we'll subtract the area of these two sectors. Let me say that area of two sector, I'll be subtracting, and then subtracting the area of the circle inside. So first we have to find out the area of the sectors. So what is the area of the sector? We know that area of sector is 1 by 4 pi r square. Theta by 360 into pi r square. Theta here is 90 degrees, so it will be 90 by 360. That is going to be 1 by 4. 1 by 4 pi r square. But there are two sectors, 1 and 2. So I just multiply it by 2. There are two sectors. So it will be 1 by 2 pi r square. So let me, and what is the radius? It is given 1.4. So let me write now things. AS, which is the area of the square. What is the area of the square? It is going to be 8 into 8. Area of the square. Now minus area of the two sectors, which is half into pi into r square. What is the area, radius? It is given 1.4 into 1.4. And then we have to subtract the area of circle inside also. This is 4.2, so radius will be 2.1. So it will be pi into r square, 2.1 whole square. This you have to find out. So this is going to be 64, and this is going to be 3.08, and this is going to be 13.86. And you get 47.06 centimeter square as the result. In this figure ABCD, ABCD is a rectangle with AB, this side, as 14. This side is 14 and this is 7 centimeter. Taking DC, that is this one, and AD, this one, and this one, BC. These as diameters, semicircles are being drawn. So there is this semicircle, and this semicircle are being drawn. Find the area of the shaded portion. So we have to find out the area of shaded portion. So what we will do, we'll take this one, and this one. 3 will add and we'll subtract this region from here. Okay. So what I have to do here is, let me say that this is 1, this whole is 2, this is 3, and now this semicircle portion, which is white, you can see this is 4. So I have to add 1 and 2 and 3, then subtract the fourth one, which is the white one. Let us say that this is fourth one. So this we have to do. So what is 1 and 3? If I combine this from here, if I combine these two, it will be a circle, almost a complete circle. So what is the area? I can just say that 1 and 3 are, I can take pi r square. It is a circle. This and this combined are pi r square. So it will be pi r square. What is the radius? It is, the diameter is 7. So 7 by 2 whole square, pi r square. This we have done. Now let us come to this rectangle. Rectangle side is, this is 14 and this is 7. So just add 14 into 7, area of this rectangle. This is also done, this is also done. Now subtracting the area of this semicircle, which is white one. So the base is this one, DC 14, so radius is 7. So we have to subtract pi r square, 22 by 7, half of pi r square, half into 22 by 7 into r, which is 7. 14 by 2 is 7 into 7. So now this, what you get, this, all these things means this as first one, which I said is 7 by 2. So you said 2 into pi r square, which was actually pi r square, this one. So this comes to be 77 by 2, this one. Then 14 into 7 is, of course, the, or let me take this one. So we have to subtract this one. So 77 by 2, 14 into 7 is 98. And this one will be 77. Okay, 7, 7 to 11, and 7 into 11 is 77. So what do you get here? For 59.5. This is the answer. In the figure, ABCD is a rectangle having AB equal to 20 centimeter and BC equal to 14. So here AB is 20, and this BC is 14. Two sectors 180 degree have been cut off. So there are two sectors, or you can say two semicircles these are. So they are being cut off. You have to find the area of the shaded region and length of the boundary of the shaded region. So now the boundary has to be found out. Area is very simple. Take the rectangle, so area of rectangle minus area of these two semicircles. So minus area of these two semicircles. What is the area of the rectangle? 20 into 14. You have to subtract the area of two semicircles. So if I combine these two, if I take this one first and this second, If I combine these two, what do we get? If we just combine these two, we get a circle. So this area will be pi r square, that is 22 by 7. And what is the radius? If this is diameter 14, radius will be 14 by 2, that is 7 into 7. So what do we get? This is 154. This is not 280. And this you go, so 22 into 7 is 154. So this is 126 centimeter square. So this is the shaded region. Now how about finding the length of the boundary of the shaded region? So we'll take DC plus AB plus this one plus this one. So I'll take this DC, which is 20, again this AB, which is 20. Then I have to take this one and this one, which is actually this one and this one, which is actually the circumference of the circle. So it is 2 pi r. It is only the circumference. So 2 into pi into r. What is the radius? 14 by 2, 7. So this will be 40 plus this will be 44. So you get 84 centimeter as the answer. In a figure this square ABCD is divided into 5 equal parts. So we have 5 equal parts here, all having same area. The central part is a circle, and the lines AE, this AE, and GC, and BF, this one, and HD, this one, they lie along the diagonals AC and BD of the square. So if AB, this is 22 centimeter, find the circumference of the central part and the perimeter of part AB, this ABEF. So this we have to find, this we have to find. Main thing is this. Okay. So now, first of all, the circumference of the central part, what it is going to be. See, first of all, we have the side as AB as 22. So all the side, because it is a square, all the side will be 22. What is the area of this whole region? Area of this square will be side square, that is 22 square. So you get 484, which is area of this whole region. Now this is divided into 5 parts. 1, 2, this is 1, this is 2, this is 3, this is 4, and this is 5th part. 5 parts. So we have 484 by 5 parts. So one part will be this one also. So let us equate it to this pi r square. We have to find out the area of this circle. So I am equating this to the radius. This is a circle and this is one of the part. And so I have just taken 484, which is the area of whole one, and we divided into 5 parts. So one part will be, I divided it to 5. So one part will be there. It will be equal to pi r square. So pi is, this r square will be, let me write it, pi 22 by 7 into r square will be equal to 484 by 5. So r square will be 484 by 5 into 7 by 22. I am taking root here. So r will come as 5.55. Now this, let me make it. So this radius is coming as 5.55. Radius is coming as 5.55. But if you see, this is 22, this is 22. What will be the length of the diagonal? What will be the length of the diagonal? We know that for a square, if this is A, this is A, this will be A root 2. So the length of the diagonal is 22 root 2. Length of the diagonal is 22 root 2. So we have to find out the circumference of the part. First let us find out the circumference, then we'll go to the next one. We already know the radius here. So 2 pi r will be the circumference. I'm first taking this one, then I'll go to this one. 2 pi r. So 2 into 22 by 7, we know the radius now 5.55. So the circumference of the central part will be equal to 34.88. So first question is done. Coming to the perimeter of the part. So as I said that this is 22, this is 22, this will be 22 root 2. So this is 22 root 2. So what will be the half of this? 22 root 2 by 2, that is 11 root 2. So this half is 11 root 2. This is 11 root 2. But if this is 11 root 2 and we have a circle and the radius is 5.5. So what will be this? 11. This whole is from here to here, half 1. From this point to this point, it is 11 root 2. And from here to here, from this point to this point, it is 5.5. So this will be my BE and AE. So we have BE and AE, so multiplied by 2. So 2 into 11 root 2 minus 5.5 will be this one and this one. Now how about this one? 22. I am trying to find out the perimeter of the part, this part. So I have taken 22, I have taken this 2. Now I have to find out this side, this side. Now if you see, this is what? This will be 90 degree. This will be 90 degree. Okay, and we know the radius also, so we can find out the area of the sector, or the length of the sector, EF. This one. So it will be theta by 360 into pi r. Theta is 90 degrees, so 1 by 4 into 2 pi r. Theta by 360 into 2 pi r is the length of the, or perimeter of the sector. So theta by 360, 90 by 360, 1 by 4, 2 pi r. 2 pi r, 2 into pi, 22 by 7 into r. And radius is what? 5.5. So what do you get? See, everything is there. The answer, if you compute it, this is going to come as 50.64. This is how we have to do it. In the given figure, find the area of the shaded region. Find the area of the shaded region. So this is the shaded region, and if you see, I have this one part, this two part. So if I combine 1 and 2, it will be a circle. Then this part and this part. If I combine 3 and 4, this will again be a circle. So I have actually two circles, because this is 14, this is whole is 14, this is 3, this is 3. So 14 minus 3 minus 3, that is 14 minus 6, and it is going to be 8. So from here to here it is 8. From here to here it is 8. From this point to this point, 8. But we have this from here to here also, this is 8. From here to here it is also 8. What is the radius of each semicircle? What is the radius of each semicircle? It will be, see, this is 2. Okay, from here to here it is 2. This is 3 and this is 3. 14 minus 3 is 8. From here to here it is 8. So from here to here it is 4. This will be 2 and this will be 2. Then only it will make 8. Because this is a square inside. So we have 1, 2, 3, 4. If you combine this, there are two circles. Means this one and this one combine one circle, and 1 and 2. And 3 and 4 we combine, we have two circles. So we have two circles. So let us find out the area of two circles. 2 into pi r square into r square. What is the radius? 2. Okay, 2 into pi r square. So we have 2 into 3.14 into pi 4, 2 into 2. And this will be 25.12. How about this one? We have the area of this central portion also. So we have to take this area also. 4 into 4. That is this one. 4 into 4. So 4 into 4 is 16. That is area of the middle square, I am saying. It is 16. So just combine this. You just combine this. This is going to come as 41.12. Now we have found the area of whole of this portion, and we know the area of the outer one, which is 14 into 14. Total area minus this area, 41.12. That is going to be 196 minus 41.12, and this will be 154.88 centimeters square. I hope you got the idea. How did we do it? This is 3. See, this is the side, which is 7. If you take the center one, this is 7. This is 3. So from here to here, it will be what? It will be 4. So this will be 2. This will be 2 because of the symmetry. Because of the symmetry I did. Now in the figure OACB, this is a quadrant of a circle with center O. So here we have a center O, and the radius is 3.5 centimeters. So if this OD is 2 centimeter, find the area of the quadrant OACB. So we have to find out the quadrant of first outer one, and then we have to take the shaded portion. So outer one we can easily find out. It is just theta by 360 into pi r square. Theta is 90. We just have to find out 1 by 4 pi, and outer one we have to find. So we will take this as 3.5. Outer one we have to find. So 3.5 whole square. This is going to come as 9.625. So in order to find out this internal, that is internal region, what we have to do? First sector, that is 1 by 4 pi r2, you can say. 1 by 2 pi r2 square minus 1 by 4 pi r1 square. 1 by 4 pi, or pi by 4 I am taking out. R2 is what? This is 3.5 whole square. And what is inside? 2 square. When you compute it, it is going to come as 6.482 centimeters square. In this figure, a square OACB, this is OACB, is inscribed in a quadrant OPBQ of a circle. If this QA, this QA, that is the side which is the radius of this sector, is 20. No, this OA is 21. This one is 21. I don't know the radius. So this OA is 21. Find the area of the shaded region. So what we'll do, we'll find out the area of the sector and we'll subtract this area of the square, and we get the answer. Let me write it as square and this as area of sector. So what is the area of sector? Theta. See, first this is 21 and this is 21 because this is a square. So what will this be? It will be 21 root 2. We know that the diagonal will be just side root 2. So we have now the radius also. So what is the area of this sector? It is theta by 360 into pi r square. Theta is 90 degrees. So we have 1 by 4 pi r square. R square. What is r? 21. We have to subtract the area of this square. What is the area of this square? What is the area of the... No, this is 21 root 2, sorry. 21 root 2 into 21 root 2. So what is the area of this square? It is side square, so 21 into 21. So we have 1 by 4 pi 21 root 2 whole square minus 21 square. Same thing which I did. So you just compute it, it will come as 252 centimeter square. So we will do the next one in the next discussion. Till then, thank you so much. Take care of yourself.